Chapter 9, Section 3 is entitled the Pythagorean Theorem. We start with some definitions and formulas and whatnot. Start off with the definition of the Pythagorean Theorem. For any right triangle, the sum of the squares of the lengths A and B of the legs equals the square of the length C of the hypotenuse. Or in other words, we're using the Pythagorean formula, a squared plus b squared equals c squared. For any right triangle, the sum of the squares of the lengths A and B of the legs equals the square of the length C of the hypotenuse. Or in other words, a squared plus b squared equals c squared. Definition of hypotenuse: the side of a right triangle opposite the right angle. The side of a right triangle opposite the right angle. In that formula up above, that's what's C. And legs, the sides of a right triangle that form the right angle. That's A and B in the formula. The sides of a right triangle that form the right angle. A and B in the formula. All right, one more time from the top. Pythagorean theorem. For any right triangle, the sum of the squares of the lengths A and B of the legs equals the square of the length C of the hypotenuse. Hypotenuse, the side of a right triangle opposite the right angle. That shows up as C in the formula. Legs, the sides of a right triangle that form the right angle. And those are A and B in the formula. Now, as you can see, just above that to the right there, I've drawn a right triangle with the parts labeled. Whenever you have a right triangle, first identify the right angle. The side that's directly across from it is always C, the hypotenuse. Whatever's left has to be the leg. Now, I will tell you that the legs, as far as which one we call A and which one we call B in the formula, doesn't matter. You can call whichever one you want A, you can call whichever one you want B. You get the same answer either way. Okay, let's go to example 1. In example 1, no story problems or anything fancy. You're just supposed to learn how to use the formula there. And you can see example 1 has A equals 18 and B equals 9. A equals 18 and B equals 9. All right, again, the formula is A squared plus B squared equals C squared. Now, in this particular problem, I have A and B. So A is going to change into 18. B is going to change into 9. As far as C squared, there's nothing at this particular moment I can do with C squared other than to call it C squared. All right. Now, 18 squared and 9 squared can be simplified. 18 squared equals 324. 9 squared, well, you know that one. 9 squared is going to make 81. Now, I'm going to add the 324 and 81. And when I add 324 and 81, I get 405. Now, that's what C squared equals. That's not my final answer, though. Look at the way I labeled the triangle. Notice on the hypotenuse, it doesn't say C squared. It just says C. I don't care what C squared equals for my answer. I only care about C. So to get from C squared to C, now you're going to have to use the things we've been talking about the last several days. You know by now that squares and square roots cancel each other out. So now you're going to have to take the square root. It's basically another form of solving an equation. So you're going to take the square root of c squared, and you're going to take the square root of 405. Now the square root of c squared, the square root of c squared is just c. Square root of 405 is 20.12. And that's how long c is. So if the one side is 18 feet and the other side is 9 feet, the hypotenuse is 20.12 feet. Now I'll tell you right up front, there are very few times, not saying it won't happen or can't happen, but there are very few times you're actually going to get whole number answers. So you should be expecting decimals here today. If you stop after the second decimal, I'm fine with that. Okay, people were asking me last hour, and that's what I've been telling everybody. All right, now, A and B, not too bad. A and C, B and C, smidge more work, so let's go there. Example 2 says A is 7.8 and C is 13. A is 7.8 and C is 13. A squared plus B squared equals C squared. Again. You're going to be sick of that formula by the end of the day. A is going to change into 7.8. 7.8 squared. C is going to change into 13 squared. Now, as far as B in this one, B is what we're going to have to take the time to solve for. So for right now, B squared is just going to say B squared. All right. So now we've got to simplify that. A couple things we can do right now. 7.8 squared makes 60.84. 13 squared makes 169. All right. Now this is the point where some people start to panic because this doesn't look like something we've seen before. But it is very much something you've seen before. If I take a moment and cover up the square there, notice then it says 60.84 plus B equals 169. Well, that's just an equation. You would solve that equation by subtracting the 60.84 from both sides. Well, guess what? Doesn't matter that it says B squared. You still do the exact same thing. You're still going to subtract that 60.84 from both sides. So that's what I'm going to do now. Alright, so I do that, and I get B squared equals 160... Oh no, sorry, 108.16. Now, just like the last problem though, I don't care about B squared. B squared is nothing. The part of the triangles are A, B, and C. So I'm now going to get from B squared back to B. And this is, again, the thing most people forget. To finish this, you've got to take the square root now. So you're going to take the square root all the way across to finish this. Take the square root all the way across. Square root all the way across gives me 10.4. Why did I write it like that? Alright. Alright, one more there. You can see this one's squeezed in right next to it. B equals 24 and C equals 26. B equals 24 and C equals 26. So obviously in this one, we're going to be fishing for A here. So, write out my formula again, just like I've started every other problem. Right. B is going to get changed into 24. C is going to get changed into 26. As far as A squared,